Hello everybody, welcome to my video over entropy. Now this video was made to help with the concept of entropy, as well as give some interesting information about where it came from, who came up with it, and let's get started. First of all, what is entropy? Well, entropy is a measure of the disorder of a system. Now what we mean by disorder, we're referring to the number of different microscopic states a system can be in, given that the system has particular fixed composition, volume, energy, pressure, and temperature. So basically it has to be a closed type of system. By microscopic states, we mean the exact states of all the molecules making up the system. Basically what entropy is, it's a macroscopic way of describing the microscopic properties of a system that, when put together, makes a difference on the entire system as a whole. To help give you a visualization, I want you to take a look at these two pictures here. The one on the left is a picture of a bustling city, and the one on the right is of a quiet neighborhood. Now, which one do you think has the most entropy? The one on the left does. The reason being is that the city has many different parts that are in many different types of states, thus making the entire system at a much higher level of disorder than the quiet neighborhood that doesn't have as many different states. The concept of entropy was first introduced in 1865 by a German physicist and mathematician named Rudolf Clausius. Interestingly, the paper in which he introduced entropy ends with a summary of the first and second laws of thermodynamics. Okay, so how do we calculate it? Well, as you can see here, this is a general form for the change in entropy, where Q is the heat flowing into the reservoir, and T is a constant temperature. For an irreversible process, the total change in entropy must be greater than 0. We can use the equation right here if we are considering both the system and its surroundings. By doing this, we can add together both their change in entropies to get the total change in entropy. Okay, so why know entropy? Why is it important, and why do we calculate it? First is to understand why heat flows from a warmer source to a cooler one, and to understand why all things in the universe tend to become disordered. As a substance is heated, its entropy increases because the motion of its molecules increases and becomes more random. Heat flows naturally from the warmer to the cooler substances because the heating of the cooler substance increases the total entropy of the system. Here are the principles that make up the concept of entropy. First of all, this is the Clausius inequality that applies to all real heat engines. Basically what the inequality states is that entropy tends to stay constant within a closed interval. However, if it's not closed, the change in entropy will be greater than 0. Here we have the entropy in a reversible process. In a reversible process, the change in entropy is equal to 0, because as you go around through a reversible process, you'll have a negative change in entropy and a greater change in entropy. Another thing to note is that entropy never decreases, it only increases. However, there is an exception. The exception is that in an open system, entropy can decrease. This is because in an open system, everything is allowed to interact. Mass, volume, heat, everything. And Because of this, energy is allowed to flow in and out of the system. Therefore, there may be a decrease or an increase in entropy. Thank you for watching this video, and I really hope that this helped clarify some of entropy and gave you some useful information.